This video is to help you understand the classwork from section 1.1.2, looking at perimeter and area relationships. So our learning target is to look at the relationship between perimeter and area and experiment with changing the area while keeping perimeter the same, which is standard 6G1. It reminds us first that many ancient cities were constructed inside great walls to protect and defend the city. The city of Carcassonne, I'm sure I'm saying that wrong, sorry, France, still exists and has a double wall about it. The length of the inner wall around the city, in other words, the perimeter, measures about 1,245 meters. The land inside the inner wall, the area, is approximately 105,400 square meters. In this lesson, we're going to work with tiles to practice measuring perimeter and area. When measuring shapes, they remind you that it can be important to look at the space the shape covers, and this space is called the area. Other times, it's important to look at the length of the boundary around a shape, which is called the perimeter. And in this lesson, we would use tiles and toothpicks to measure these two attributes. Attributes are characteristics. The attributes in this case are area and perimeter of various shapes. So if we were going to look at this shape right here, what they're doing is showing the toothpicks here along the side, okay? And the toothpicks, the number of toothpicks is the perimeter. How many toothpicks does it take to create the outside edge? So if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, we would say that it takes 14 toothpicks to surround the shape, okay? If we look at the inside, how many tiles there are that create the space or cover the space inside, we've got 3, we've got 6, we've got 9, so we would say that there are 10 tiles, all right? So the attributes of this shape would be that there are 10 tiles, or in other words, the space inside is 10 squares, and that it takes 14 toothpicks to go around the outside edge. They also remind you that you can address the relationship between the tiles and the toothpicks by saying it in this way. It takes 4 more toothpicks, because 14 compared to 10 is 4 more. So it takes 4 more toothpicks to surround the figure than tiles to fill it. All right. So what they wanted you to do first would be to look at some different tile patterns and to, count out and figure out how many tiles does it take to fill the inside and how many toothpicks does it take to surround the outside. All right. So if we look at this picture, Savannah said it was 10 toothpicks to get the outside edge. Cruz said there were 6 tiles inside. They wanted you to make a copy of this and show where you see the 10 toothpicks, where you see the 6 tiles. Then, if you look at this new picture, how would you describe this shape in terms of toothpicks and tiles? In other words, how many toothpicks does it take to go around the outside edge here? How many tiles does it take to fill or create that shape? All right. Then you'd be doing some individual work and some teamwork on that. And then the last thing that they have you doing is looking at some figures that are drawn, as well as some facts about them, and trying to match them up. So, for example, you could, and my suggestion would be, in each of these, figure out how many tiles and how many toothpicks. Then once you know that, match it up with the correct fact. All right, now the facts are what sometimes students find confusing. So one fact, or fact 1, is that the figure contains 8 more toothpicks than tiles. You'd be looking at one of these shapes where the number of toothpicks, in other words, the perimeter, the outside edge, is 8 more than the area, the number of tiles inside of it. Fact 2 is that the figure has 2 more toothpicks than twice the number of tiles. So if you took 2 times the number of tiles, 2 times the number of tiles, or 2 times the area, and then you added 2 to that, that should be how much toothpicks it requires, or how much perimeter it has. And then fact 3 is the figure contains half as many tiles as toothpicks. So the number of tiles should be half as much as the number of toothpicks. Fact 4 is just that the figure contains 12 toothpicks. And fact 5 is that the figure has an even number of tiles and toothpicks. Even number meaning, of course, a number that's divisible by 2. So 2, 4, 6, 8, 10, 12, 14, and so on. It needs to have an even number for both the tiles and the toothpicks. And the reason I suggest first writing down how many tiles and toothpicks in each section and then matching them up is that you might find, a fact may seem to, fit more than one category, but yet once you go through them, you'll find that each one, if you're only going to pair it up with one, each one has to go to a certain fact. All right. So that's important to figure out. All right. Then for 1/8, they want to know if you change the number of toothpicks, does that always change the number of tiles? And if you change the number of tiles, does that always change the number of toothpicks? All right. So first of all, they have you looking at this figure and saying how many tiles, how many toothpicks. And then for B, what if you would add a tile? Could you put it in a place where it would not change the number of toothpicks? All right. Also, you'll notice that at times they bring up these sections, and if you click on those on your ebook, it allows you to actually play around, so to speak, with the tiles and toothpicks. In other words, if you bring that up on your CPM ebook, you can move tiles over, you can move toothpicks over, and really get a chance to experiment with that idea, even if you don't have tiles or toothpicks at home. Then for 1/9, they remind you that the perimeter of a design is the length of the boundary around the outside of the design. In other words, the toothpicks. So the number of toothpicks is equivalent to the idea of perimeter, and that the number of squares needed to fill the design is equivalent to the area. So the number of tiles is equivalent to area. So then this time, look at this design, but this time describe it with the word perimeter and the word area. In other words, how many toothpicks, but use the word perimeter. How many tiles, but use the word area. And then build and draw a different shape that would also have the same information. Same number of toothpicks, same number of tiles.